In today's video, we're going to be solving absolute value inequalities from the standpoint of Algebra 2. So we are assuming that you are basically familiar with what an inequality sign is. That would be the less than sign, the greater than sign, the less than or equal to, the greater than or equal to, and then absolute value bars. Very quickly, those would be seen as two vertical bars around a number, and that means if it is negative, turn it positive, and if it is already positive, then it stays positive. However, none of that is going to help you with what we're about to do when you are solving inequalities. So let's just take a look at the basic process. You are going to first use inverse operations to get all of the numbers and whatnot terms away from the absolute value bars so that the absolute value bars are alone. And you'll see what that means on the next slide. Then you're going to make two separate equations, and one of them is going to be equal to the positive version of the number, and the other one is going to be equal to the negative version of that number. Let's just get to it. It's going to make more sense. So, in this first example, the absolute value bars are already considered alone. There is nothing around those bars in front of it, like if the number 2 right there. There is nothing behind the bars, like if you were adding 2 right there. So that means you are good to proceed with the next part of the process. Once again, the process. Once the bars are alone, you're then going to make two equations. So let's do the process. They're already alone. Make two equations. Okay, here we go. So your equations are going to be, take a look at this very carefully. You drop the bars, and then one of them is equal to the number that you see there, in this case, the number 3, and then you make the exact same equation with the same 1 over 4x minus 1, but you make it equal to the negative of whatever the number was that you started with. So one of them, again, just jumping back to this, one is going to be positive, one is going to be negative. So now that we have our two equations, you just solve normally. So you would add 1 to both sides. In both of these cases, you might as well do them both at the same time. Multiply both sides by 4, and you get x equals 16 and x equals negative 8. But we're not done. You are not done until you draw the graph. So negative 8 is less than 16, so it would be the number that is on the left-hand side right here. Let me just change that highlighter color. There we go. All right, negative 8 would be less than 16, so that is why negative 8 would be on the left side of this number line right here. And then this is the part that you need to know. Because we have, listen up, because we have the greater than sign, this problem is called an OR problem. What does that mean? Well, x could be less than negative 8, or it could be greater than 16. It's one or the other. It's either going to be on the left or it's going to be on the right. That's why it's called an OR. But you don't need to know that. All you need to know is that if you see the greater than sign, oh, the highlighter made that go away. If you see the greater than sign in the problem, you know that after you get your answers, you need to shade on the outsides, the opposite directions. That's just what this style of problem is supposed to look like. So that's what you got to do. Oh, and you will also notice that both of these circles are open circles, and that is because we use the greater than sign, or what I mean is if we had had the greater than or equal to sign, then the circle would have been shaded in. You'll see that on a later problem. Just had to say that. Oh, yeah. And when you write your final answer, forgot to also mention that, you draw your number line and you also write it as an inequality. In this case, you can see the word or right there, and you can see that's another one. Enough of this. All right, number 2. You would start this problem by adding 12 to both sides. Then we now have the bars alone. So now that the bars are alone, you need to make two equations. Here we go. So in both of these cases, we will add 12 to both sides. Oh, forgot to say the most important part. My bad. Remember, you will always have a positive version of that number and a negative version of that number when you make your two equations. This will always be positive in this scenario. I'll tell you at the end what to do if the 8 were negative, but that's coming up at the end. In both of these cases, add 12 to both sides. Divide by 3. Don't be afraid of that. It's just a fraction. Fractions are numbers too. And you get 20 over 3 and 4 over 3. Let's put them on a number line. 4 over 3 is less than 20 over 3, so it should be on the left-hand side of the number. And then now notice, all that animation happened quickly, but whatever. The less than sign. So in the previous problem, we had the greater than sign, and that was an or problem. This is the other situation, the less than sign. This is called an and problem, and you're going to shade the middle of the graph. You can see that right there, just highlighted it in yellow. An and problem has an inequality that looks like this, with the x in the middle, because you shade the middle. So just to compare these two one more time. Greater than sign is an or problem. You're going to be shading the outsides of your graph, and you're going to have two inequalities for your answer. The less than sign is called an and problem, and that means you shade the middle of your graph, and the x is going to be in the middle of your inequality, but you only have one equality, you don't have two. All right, enough of that. Here's another one. Maybe pause the video, give it a shot, and all right. Divide by 2. Look at that. The number is in front of the absolute value bars. Divide by 2, and then the bars are alone, so make your two equations for the last time. You have a positive 4, you have a negative 4. That's just part of the process when you are solving an absolute value equation or an inequality. And I could talk about why, but you're not interested in that. Let's just get to how to do it. You could subtract 14 from both sides. Bring down that negative 2x. Keep in mind that negative sign has to stay with the 2x. Divide both sides by negative 2, and you get 5 and 9. Now, one last time about this concept. I wasn't repeating that enough. Notice how it says greater than or equal to. Of course, we know that the greater than problem means it's an or, so you're shading the outsides, but we have that line underneath, and I have not been repeating it enough that you will be filling in the circle when you draw your graph. And it were just the greater than sign, then it would be an open circle. And then also notice at the bottom, you have two inequalities. All right, moving on. The last point that is now going to be addressed that was not being addressed before. What to do in those infinite and no solution scenarios. This is very easy. Maybe pause and write this down or just listen, whatever. So this is only something you do when the bars are alone. So you have done all of the work to get any numbers in front or behind the bars away. And then you assess the problem. If you have a negative number on the other side of the inequality, again, notice there is nothing in front of this absolute value bar anymore. There's no number being added or subtracted. The bars are alone. If the sign is less than or the less than or equal to sign, that is called no solution. Again, if it is the less than, let me get that purple out of here. Let's bring in another highlighter color. Not yellow, orange. So less than or equal to, can see it right there. If that is the situation with having a negative number, then that means there is no solution. And then if it is the greater than or equal to sign, like you can see in the top example, that is where you will have all real numbers or infinite solutions. And just to, I guess, basically explain it, if, let's just take the first case. If you have absolute value bars that are supposed to be greater than -6, remember from the beginning of this lesson, I told you when you have the absolute value of a negative number, it becomes positive. If you have the greater than sign here, well, duh, anytime you take the absolute value of stuff, it's always going to come out positive, and every positive number is going to be bigger. No matter what positive number it is, it's going to be bigger than every negative number. So that's why all real numbers is the answer that you would write down if you are in this scenario. And then the opposite is true for the second situation. If you are less than, in this case, there it is, less than a negative number, that doesn't make sense. Again, the absolute value bars turn a number positive. How could you turn this statement positive, but then it's less than or equal to a negative number? That doesn't make sense. Therefore, there's no solution. And if that doesn't make sense, then whatever. Then write that down and do it in those situations. All right. Practice some problems. Here they are. Pause the video. Don't pause the video. Whatever. I'm going to let these problems play through at a slower speed so you can kind of see the work. Thank you for watching. Drop a question in the comment. Hope you enjoyed it. See you next time. This is pretty slow. Let's make this a little faster. Oh, geez, something else I forgot to talk about. Oh, my gosh. You've been staying this entire time. Great. One last thing with inequalities that I forgot to mention. You can see it right here in example 3. Forgot to mention, if at any point you multiply or divide both sides of an inequality by a negative number, you have to flip the inequality sign around the other direction. And you can see that right here in purple. Forgot to mention that, but hey, you know what? You're supposed to have taken Algebra 1 if you're watching this video, and if not, there's a great review.